All right, and the last example is going to be evaluate the absolute value of an expression at x equals 0. So a couple of things I want you to remember about the absolute value. When I have the absolute value of, let's say absolute value of x is equal to 2, okay? What that means is x could equal a positive 2 or x could equal a negative 2, right? Because whenever you take the absolute value of a number, it's always going to turn it to the positive distance away from the definition of the absolute value means the absolute distance away from 0. So it could be in the positive or in the negative direction. It's just talking about the absolute distance away from 0. And again, like you can see this, right? If we were to look at like 0, like here's 0. So here's negative 2 and here's positive 2. Wouldn't you agree that both of these are a distance of 2 away from 0? That's what the absolute value represents. Now, when we're evaluating, all we're simply going to do is whenever we see an x, we're going to replace that with a 2. That's what evaluate for that expression at x equals 2 represents. So what I'll do here is I have a 4, absolute value of 1 minus parentheses 2, and then end absolute value. So whenever I'm doing evaluating, whatever I'm plugging in for, I always like to put parentheses around there. That one triggers me to remember what actually I'm replacing. Like I replaced the 2 for the x, so that reminds me of that. Always also, a lot of times like our absolute values can sometimes be confused with like a 1. So always make sure they're nice and kind of like distinguished here. So in this case, I have a 1 minus a 2, which is going to be a negative 1. So I have a 4 absolute value, it's 4 times an absolute value of negative 1. And absolute value of negative 1 is just going to be a positive 1, right? Because the distance away from 0 is just going to be 1. So it's a 4 times 1, which is equal to a 4. And again, you can see how I'm kind of working things out step by step here. But again, the other thing I want you to mention is it doesn't really matter what's outside the absolute value, right? We're only concerned about, well, it does, but I'm like, what you want to do is simplify the absolute value first, and then you can worry about whatever is happening on the outside. So for example, here, like a lot of students will see this negative 2 and they're like, oh, let's make this a positive 2. No, that's outside the absolute value. Leave it right there. So now I have a negative 1/2. This is going to be, we're going to plug in a 2 here. So 2 plus 1. Now here comes a little bit of fraction. So just remember, like if I had a negative 1/2, right, times 2, remember you can rewrite that 2 over 1, right? Now the 2's, you could like multiply straight across, like that's a negative 2 over 2, which is equal to a negative 1, right? Now sometimes you could like cross things out. I don't really like crossing things out. I think it's just easy to multiply straight across and then simplify. But again, you can see that this is going to be at a negative 1. So I have a negative 2 times, let's see, this is a negative 1 plus 1. Well, negative 1 plus 1 is going to be a 0, right? So absolute value of 0 is like, what's the distance away from 0 at 0? Well, it's just 0, right? So negative 2 times 0 is just going to be a 0. All right, and in this example, we have a negative x squared plus 1. So again, let's just plug it in. So negative 2 squared plus 1. Now, this problem is different than the one, if you remember, where I plugged in that negative 3. This one's technically saying a negative 1 times a 2 squared, right? So there's a really big difference here. We're not squaring a negative 2. We're not squaring a negative 2. This only thing that's being squared is the x. So when I plugged in a 2, that only the 2 is being squared. So this is going to be a negative 1 times a 2 squared. Well, that's going to be a 4. So that's going to be a negative 4 plus 1. And a negative 4 plus 1 is going to be a negative 3. And that's just going to equal a positive 3.